Hello everyone, my name is Wei Leng and currently I'm a student from Taylor's University, and currently I'm a year 2 student taking Actuarial Science. So this video is tailored for one of our modules called Risk Theory, and I was given the task to give a tutorial to teach you guys, whether you are from the actuarial field or you're from the non-actuarial field, on one of our computer-based test questions. So without further ado, let me just share my screen first to share with you guys the question that I was given. All right, so the question that I was given to give a tutorial on is question 3. And the question is, a claim count distribution can be expressed as a mixed Poisson distribution. The mean of the Poisson distribution is distributed as below. Okay, so before I dive into in-depth into this question, let me just give you guys a recap on what is a Poisson distribution. Okay, so a Poisson distribution, I'm just going to give you guys a quick rundown. So a Poisson distribution is a discrete distribution, and the function of this distribution is to describe that it describes the number of events occurring in a fixed time interval, or in a sense, in a more technical way, it's called a region of opportunity. And Poisson distribution usually requires only one parameter. And in this case, it's lambda. I'm sure a lot of you guys have seen this before. Okay, so however, in the question just now, as mentioned, it's a mixed Poisson distribution. So let me give you guys a scenario to depict this in a more better way. Okay, so let's say X is your number of claims. So in order to obtain X, you will have 3 parameters. For example, you have high risk, average risk, and low risk, each with their own lambdas here, lambda 1, lambda 2, and lambda 3, which is for high risk, average risk, and low risk. But however, imagine that in high risk itself, we have other specific conditions. For example, I'll give you guys a few scenarios. Under high risk, let's say an insured is young, but he has stage 4 cancer. And another insured is old, but he has heart disease, which places them in high risk. As for the average risk, let's say this person is young, healthy, but he has a risky job. And finally, in low risk, let's say this person is young, healthy, and he has a normal job. So what do these conditions actually tell you? We can actually categorize them further into more categories. So, and in this case, we can categorize them into, let's say, age, their health status, their jobs. And why did I mention that it may not be classified very clearly is because, for example, if you say that the job is very risky, but how do you measure how risky the job is? And maybe, and also another factor we can take into consideration is that an accident will happen to the insured. And imagine if you have 100 more of categories in order to just calculate the number of claims that you have for a particular policy. It would be very confusing, right? And it would require a lot of calculations. However, in this question, it tells us on how to integrate all these conditions into a single distribution to calculate the number of claims, which is your X. Okay, so let's move on. Okay, so what's a mixed Poisson distribution? So a mixed Poisson distribution is a distribution which models the number of losses or claims arising from a group of risks where the risk level among the group contains heterogeneity. So what is heterogeneity? It means that it has a lot of variation. like for example here, the scenario that I've mentioned just now, you have like age, health status. Each of them have their own specific lambda. Each of these categories or conditions will give us a different number of claims. So this is just a scenario that I've depicted for you guys, but let's go dive deep into the question that we were tasked just now. Okay, so as you can see here, we have lambda equals to 1, lambda equals to 3, lambda equals to 5. We have so many lambdas here. So right now, the first thing that we have to do is on how should we integrate or merge all these lambdas into a single distribution. Okay, let me just move on to the Excel folder. Okay, before we begin, okay, so do note that in Poisson distribution, your mean and your variance is equals to your lambda. So these two columns here are the given information. And then before I go into how we will calculate the overall mean, which is your EY here. So the formula for EY here is EY equals to the sum of your weight of each mean. So this is your specific lambda for each condition. Specific lambda for each condition. And then in order to calculate the weighted average of your EY, that is the overall mean for your whole distribution, you will have to multiply this value with this value, which you will get 0.25. And so on, moving down the table, you continue to multiply the probability, which is your weight, with your individual lambda. And after that, you sum it up, you will get 7.592. And then moving on, we want to get the variance of Y. Okay, so in order to get variance of Y, we have to calculate the second moment, which is the sum of your weights and the second moment of Xi. Okay, do note that why can't we directly calculate the individual variances of each of the lambda and just sum them up together. Okay, do take note that, sorry. You cannot apply this formula in this context. It is wrong. So instead, we will have to calculate it in this way. Variance Y equals to second moment of Y minus the mean time to the power of 2. So in order to get variance Y. Okay, so the same procedure as it is, we get e to the power, the second moment of individual xi's, and then we multiply them with the weights, which is the probability, to get weights times individual ex. And then finally, we sum them up in order to get the second moment of Y. So that's when we can calculate your variance of Y, which is using this formula. Hold on, just using this formula here. The second moment of Y minus your mean power squared. So that's how you get your variance. Okay, moving on to the second question. The second question requires us to calculate the probability of the claims that are greater than 11. Okay, so how should we do this? If it's handwritten calculation, of course, you have to calculate each probability of Poisson distribution, which is with the formula e power negative lambda, lambda power n, and power n factorial. Okay, however, we are not going to do individual calculation for each of the lambda. In this context, we are only looking for claims that are greater than 11. However, imagine that if you are given the task to calculate a number of claims which is greater than 100, you're not going to calculate all 100 of them in order to get the accumulated value, right? So in here, we are going to use the function in Excel, which is called equal Poisson dot distribution. And the parameters in this function is n, and then your lambda, and then its cumulative equals to true. Okay, so in this context, how I did this is that Poisson distribution, and we want claims that are greater than 11, which is greater than 11 exclusive. We exclude 11. So our n here is 11. And then our lambda is 7.592. And then your cumulative would be true because you want to get the accumulated value from 0 claims to 11 claims. Okay, so using this formula, we have gotten 0.915259. However, the region that we want is your probability of your y greater than 11. So how do we do this? Is that we use 1 minus so your PR would be y greater than 11 equals to 1 minus your probability of y less than 11. So that's how you get the final answer of 0.084741. Okay, I hope, sorry for the mess in the sketching here, but I hope everyone understands how should we approach this question, which is using the mixed distribution method. And I hope that my friends who are from the actuarial field and also from the non-actuarial field would be able to gain much knowledge from this video. Thank you guys, and hope to see you guys soon.